Imagine you're evaluating two AI-generated responses to a complex image question. One response is concise and factually accurate. The other is rich in detail, creatively expressive, but contains a subtle hallucination. Which one should win? In traditional AI evaluation, you pick one winner based on an overall preference. But what if the best answer depends on what you value most? Accuracy, creativity, clarity, or visual grounding? This is the core challenge that most multimodal judges struggle with, and it's why a new benchmark called Multicrit is changing how we assess AI reasoning and judgment. For years, AI evaluation has relied on a single preference label, A is better than B, across a pair of responses. But this approach hides something critical: conflicts between evaluation criteria. Take this example. An AI model describes a child on a toilet in a photo. Another describes a chimpanzee on a chair. The task: find the one that mimics the child's pose, hands on hips. Now, neither candidate perfectly matches. But one is a chimpanzee, closer in species. The other is wrapped in a blanket, which mimics the towel in the original. So which is better? If you value visual grounding, the chimpanzee wins. If you value factual accuracy, the blanket response might be better, because it mimics the action, even if the animal is wrong. This isn't a minor detail, it's a trade-off. And yet most benchmarks ignore it. Multicrit isn't just another benchmark. It's the first to expose and measure how well multimodal judges handle conflicting criteria. Each evaluation sample includes multiple criterion-level annotations, not just one final verdict. For every prompt, human experts label which response is better under each of 5 key dimensions: completeness and coverage, visual grounding, factuality, no hallucination, expressiveness, clarity and coherence. And crucially, they do this independently. So we can see where models agree and where they disagree. Multicrit wasn't built from scratch. It's the product of a meticulous data curation process. 1. Diverse prompts from 8 real-world sources: Wild Vision Bench, DOCCI, Mathverse, Emma, and more, spanning both open-ended generation and verifiable reasoning tasks. 2. Challenging response pairs, generated by 11 top models, proprietary and open source, then filtered to keep only cases where responses differ subtly but meaningfully. 3. 3-stage filtering. Remove extreme length disparities. For reasoning tasks, only keep pairs where both answers are correct or both are wrong, so we're testing quality, not correctness. Use 3 strong judges: GPT-4o, Gemini 2.5 Flash, Claude 3.7 Sonnet, to eliminate unanimous cases. Only keep pairs where the judges disagree, the real test of fine-grained judgment. 4. Human annotation. 9 PhD-level annotators, cross-validated with a Cohen's kappa of 0.718, open-ended, and 0.805, reasoning, meaning high interannotator agreement. 5. Conflict detection. Over 782 conflict pairs, where the same response wins under one criterion but loses under another. To assess judge models, Multicrit introduces 3 novel metrics. 1. Pluralistic accuracy, PAC. Measures how often a judge gets all criteria right on a single instance. The average: just 32.78% for open-ended tasks, even for top models like O4 Mini. 2. Trade-off sensitivity, TOS. How well does the model detect when criteria conflict? A high TOS means the model doesn't default to same answer for everything. But here's the catch: GPT-4o has the highest TOS, yet it fails to resolve conflicts. 3. Conflict matching rate, CMR. The strictest test: can the model correctly resolve a conflict in line with humans? Only 33.7% in open-ended, 47.7% in reasoning for open-source models, far below their proprietary peers. When we evaluated 25 LMMs, the findings were sobering. 1. Even the best struggle with pluralism. O4 Mini, the top performer, achieves only 32.78% PAC in open-ended tasks. In reasoning, it reaches 53.17%, still far from perfect. No model excels across all criteria. GPT-4o is great at expressiveness, but weak on completeness. O3 dominates on hallucination, but lags in expressiveness. 2. Open-source models are falling behind. Proprietary models lead across all metrics: PAC, TOS, CMR. Open-source models like Intern VL3538B and QN2, 5VL72B Instruct show much larger drops in CMR, meaning they fail to resolve conflicts even when they get individual criteria right. 3. Critic fine-tuning isn't the answer. Models fine-tuned as judges, like El Lavier Critic or R1 Reward, improve visual grounding. But they fail to generalize to pluralistic, criterion-aware judgment. In fact, some worsen trade-off sensitivity and conflict resolution. This suggests current critic training is too narrow, focused on holistic preferences, not fine-grained multi-criteria reasoning. 3 additional analyses uncover more troubling truths. 1. Reasoning fine-tuning weakens trade-off recognition. Models trained via RLVR on math and reasoning tasks improve on accuracy, but their ability to detect criterion conflicts drops. They become overconfident in one direction, even when trade-offs exist. 2. Test time scaling is inconsistent. Majority voting across multiple inferences helps, but only for the strongest models. O4 mini gains from 32.78% right arrow, 37.12% in open-ended tasks. But other models show inconsistent, even negative gains. So scaling isn't a universal fix. 3. The human upper bound is real. For proprietary models, the highest criterion accuracy correlates strongly with human interannotator agreement, R equals 0.73. Open source models. No such correlation, R equals 0.36. This means proprietary systems are approaching human-level consistency, but open source models are still far from internalizing that standard. We're moving toward AI systems that evaluate themselves. But if the judge can't follow multiple criteria, can't see the trade-offs, then the feedback loop is broken. Multicrit isn't just a benchmark. It's a diagnostic tool that reveals where models are brittle, where they hallucinate under pressure, where they default to one metric, ignoring others. It shows that consistency is not the same as correctness, that a model can be accurate in one dimension and fail in another, and that no current judge model reliably handles pluralistic evaluation, even the best. The future is towards steerable AI evaluation, where judges don't just say, "Oh, is better," but explain why, under which criteria, and where the trade-offs lie. It challenges us to build training data that reflects real-world evaluation complexity, design metrics that go beyond single labels, train judges not just to be consistent, but to be flexible, aware, and balanced. Because in the real world, no one asks, which answer is best? They ask, is this answer factually correct? Is it clear and well-structured? Does it capture the visual details? Does it avoid hallucinations? And the answer might be different for each. We've spent years building models that generate. Now we must build judges that think. Multicrit isn't just a benchmark, it's a mirror. And what it shows is clear. We're not there yet. But for the first time, we know exactly where we need to go.